Okay, so here we have problem 1 from test 2 from the test prep books TSI preparation. Here we have x squared minus 2x minus 8 equals 0, and we're asked to find x. There are two ways we can solve this problem. The first, and the more expected way, is to use the quadratic formula. So the quadratic formula is given as x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, this formula can be difficult to remember, so there's a little song that a lot of us learn when we're learning the quadratic formula. You kind of think of it as going along to the tune of a jack-in-the-box. So you think x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that'll help you to remember it. Kind of a funny little song, but it'll help you to remember it. Now from this formula here, we want to note that a is the value in front of x squared, b is the value in front of x, and c is the value in the numeral digit. So if we plug all these values into our equation here, we will get negative b in this case is the negative 2, don't forget the negative sign there, plus or minus the square root of, again, negative 2 squared minus 4 times a, which is 1, because there's nothing in front of the x squared. And then c is negative 8, again, don't forget the negative sign. All of this divided by 2 times 1. Alright, now if we go ahead and start simplifying, we'll do simplification one step at a time. So we'll first carry through the negative sign here, and we get positive 2. Plus or minus the square root of negative 2 squared is going to be 4. And then negative 4 times 1 is negative 4. And then negative 4 again times negative 8 is positive 32. So we've got 4 plus 32 inside the square root. And then on the bottom we have 2 times 1, which is 2. We carry this one more step. 2 plus or minus the square root of 4 plus 32 is going to be 36. All this divided by 2. And the square root of 36 just so happens to be 6. All of this again divided by 2. And finally, if we carry through the 2, we get 2 divided by 2 is 1. Plus or minus 6 divided by 2 is 3. Now, I haven't really explained here so far what the plus or minus means. The plus or minus indicates that there's going to be two answers. One is going to be 1 plus 3, which is 4. The other is going to be 1 minus 3, which is negative 2. And so this will be our answer. Alright, previously I mentioned there were two ways we can solve this. The other way is through factorization. And it so happens that this problem is easily factorized, so we're going to factor it out. Starting with our original equation, x squared minus 2x minus 8 equal to 0. What we want to do when we factor is we want to get into a form that looks like this, where we have two sets of parentheses, one with an x on each one, and then we're going to have some addition of a factor. We don't know what that factor is, so we'll call those factors a and b. And if they wind up being negative, then the negative sign will just be built into the a and the b. Okay. So we want to get into this form. Alright, so the x times x here, when we FOIL this out, when we multiply this out, that will give us our x squared. So the first term in our factorizations are already figured out. The next thing we need to do is we need to figure out how do we get negative 8. And the way we do that is we use what's called a factorization tree. So if I take negative 8 and I think about what can give me negative 8. Well, we can get a 1 or an 8. And if we have a positive 1, we need a negative 8. If we have a negative 1, we need a positive 8. So here I use positive 1 plus or minus 1 or minus plus 8 to indicate that they have to be opposite signs. Then we also have 2 and 4. So we've got plus or minus 2 and minus and plus 4. So these are the factorizations of negative 8. We've got plus or minus 1, minus plus 8, with plus minus 2 and minus plus 4. These numbers then, or these two sets of numbers, so either plus 2 minus 4, minus 2 plus 4, plus 1 minus 8, or minus 1 plus 8. These four sets of values are our candidates for A and B here. We figure out which of them is going to be A and B by setting them equal to negative 2x. And it's going to be AX plus BX. If you're wondering where this comes from, when we do our FOIL, we have our outer x, our first is the x squared, x times x. Then we have x times b and a times x. These are the center values. And finally a times b. A times b is already covered with this middle step, finding the factorization of negative 8. So what we're looking at here is a times x is this term, and b times x is this term, the outer term and the inner term. So we know negative 2 needs to be equal to a plus b times x, and we need to use these values. If we look at our different possibilities here, we need to get negative 2, and the only one that works here is when we have a negative 4 and a positive 2, and that will give us negative 2x. So now if we plug this back in, we get x minus 4 times x plus 2 equal to 0. And if we divide by either one of these equations, what we'll wind up with is we'll get the opposite equation equal to 0, and we get two different equations. And if we solve each one for x, we get x equal to 4, x equal to negative 2. And this is not in the same form as this, but if we look at it, it is in fact x equal to 1 plus or minus 3. So we get the same answer. We just need to look at what is 1 plus 3, that's 4. 1 minus 3 is negative 2. Alright, here we have problem 2 from test 2 from the test prep books, TSI assessment preparation. Alright, so we have an equation, y is equal to 3x minus 2, and we're asked to determine which of the following lines is parallel. Now before we start breaking down each of these individually, we should know that parallel lines have the same slope. Now we've talked about slope in previous problems that we've worked through, but slope, if we recall the slope-intercept format, is y is equal to mx plus b. This is called slope-intercept form of a linear equation, which just means a straight line, where x is your input, y is your output, or your independent and dependent variables, as they're sometimes called, and m is your slope, and b is your y-intercept. So in this format, our slope m is simply the change in vertical position over the change in horizontal position. We call this rise over run, or delta y over delta x, where delta just means y2 minus y1 over x2 minus x1, where we're using a second point and a first point. And if we look at a basic graph, if we have point 1 and point 2, so we'll call this point 2, this one point 1, we're looking at y coordinate of the point 2, x coordinate of point 2, y coordinate of point 1, x coordinate of point 1, where our x axis here and our y axis here. So we get our x1 here, y1 here, x2 here, and y2 here. Okay. So Now that we've recalled basic information about the slope, when we have parallel lines, it should then be obvious that if we have parallel lines, they should have the same slope. Now, looking at our answer choices here, none of these are in a form that's easily, that the slope can easily be determined. So what we want to do is we want to rewrite each of these into that slope-intercept form, or a form where the slope is easily seen. So if we start with answer choice A, we have 2y minus 6x equal to 2. If we add 6x to both sides, we are left with 2y equal to 2 plus 6x. If we then divide both sides by 2, we're left with y is equal to, I'm just going to rearrange, 6x divided by 2 will be 3x, and 2 divided by 2 will be 1. So this is in our same format, and here we can see our slope is 3, and our original slope was 3, so our answer choice is going to be A, but let's go ahead and go through each of these examples just for extra practice. Alright, next we have y minus 4x is equal to 2. If we add 4x to both sides, we're left with y is equal to 4x plus 2. Again, I'm just rearranging so the x is out front. You can see again 4 is not the same as 3, so this is not our choice. The next one is going to be 3y equal to x minus 2. In order to solve for y, we just need to divide by 3, so we divide both sides by 3. We get on the left side, we get y. X divided by 3, there's an understood 1 in front of the x, so that becomes 1/3 x. Minus 2 divided by 3 is simply 2/3. Alright, finally we have 2x minus 2y equal to 2. If we first subtract 2x from both sides, we are left with negative 2y is equal to negative 2x plus 2. If we then divide both sides by negative 2, so that we get y by itself, we'll get y on the left side. Negative 2x divided by negative 2, the negative 2's will cancel and we're left with positive x. Then we have 2 divided by negative 2, 2's will cancel but the negative side will come in, so we get an x minus 1. Alright, so looking at all these answer choices, we can see that the only answer that has a parallel slope is going to be answer choice A. Alright, here we have problem 3 from test 2 from the test prep books, TSI assessments. Alright, so in this problem we're given a couple of important pieces of information. The first is that there are 10 cans of paint. The second is that a can of red paint costs $1 while a can of blue paint costs $2. And then finally that she spent $16 in total. We're asked then to determine how many red cans she bought. So this is kind of a word problem, it's a little tricky to figure out, but the important thing to do here is we need to develop a system of equations. So we need to note that first off we have 10 cans of paint. So our total number of cans is 10, right? And that 10 cans is made up of red and blue cans. We'll use the letter R to represent the number of red cans and B to represent the number of blue cans. So then we can say that 10 is equal to R plus B. Next, we can say that the total cost is going to be $16, where each red can costs $1, so we'll just write R because the 1 is understood, and then we'll write 2 times B because each blue can costs $2. So here we have a cost equation, and here we have a number equation. All right, now that we have our system of equations, we can solve this one of 2 different ways. The first way is called the substitution method. Substitution method. Alright, with the substitution method, we simply take our 2 equations, we find one of them, and solve for one of our 2 variables, then plug that variable into the other equation. So this will be a little clearer when I show you the example. So if we start with our two equations, we can see that the first equation, 10 is equal to r plus b, that's a little bit of an easier equation. Now since we're trying to solve for r, what I want to do is I want to solve this equation for b so that we can plug it into our other equation, eliminate b, and be left with only r. And again, this will be clear in just a second. But what I want to do to solve for b is I'm going to subtract r from both sides. And that leaves us with b is equal to, and I just flip the equation around. So we have b becomes the left side, 10 minus r on the right side. That's our equation that we're then going to plug into our second equation, which is 16 equal to r plus 2 times b, which is 10 minus r. Okay. Now I need to simplify this equation. So we have 16 is equal to r plus 2 times 10 is 20. 2 times negative r is negative 2r. Again, simplify one more step. 16 is equal to r minus 2r is going to give us negative r plus 20. Alright, now I want to subtract, or rather what we'll do is we'll subtract 16 from the left side, or from both sides, and then add r to both sides. That way we don't have to do an additional step with dividing by negative 1. So we get r on the left side, and then 20 minus 16 is 4. That is our answer. We don't even need to solve for b when we use the substitution method. Alright, the other method we can use is called the elimination method. With the elimination method, we simply write our two equations, and we're going to treat each of these equations as its own variable. So we'll assign a Roman numeral to each one. We'll call this I and this one Roman numeral 2. So Roman numeral 1 and 2, these are our two equations. And we want to come up with an equation using Roman numerals I and 2, or 1 and 2, such that we can get variables to cancel and we'll be left with one variable. So one way we can do this is simply by doing 2 minus 1. And what we're trying to do here again is if we take 16 minus 10, that's going to be 6. R minus r, r is cancel, which is what we want. We want to cancel one of our variables. And then 2b minus b will leave us with b. So we'll solve for b, then we'll plug that back into one of our equations and get r. Again, this might be a little weird, but what we're doing is we're just adding or subtracting vertically. So if we take our 16 equals to r plus 2b, and we're going to subtract, on the left side we've got 10, and then on the right side we've got r plus b. We add them vertically, so 16 minus 10 is 6, r minus r gives 0r, and then we have 2b minus b is b. Alright, so there we have b is equal to 6, and then if we take our original equation here, 10 is equal to r plus b, and we'll just plug in b as 6 here. If we subtract 6 from both sides, we find that r is equal to 4. Both of these methods are relatively similar in terms of the amount of work you have to do, but there are some cases where elimination method is much easier than substitution, or vice versa. Alright, here we have Problem 4 from Test 2 of the Test Prep books, the TSI assessment. Alright, so in this problem we're given the following information. There are 20 men. These men have a median weight of 180 pounds, and the range of their weight is 30 pounds. If each man gains 10 pounds, which of the following are true? And I've shown the answer choices here on the screen. Now, before we get into solving this problem, I want to give a brief overview of some statistical terms that you might not know. The first such term I want you to know is the term range. Range is simply, as the name implies, the range of values from the smallest value to the largest value. So for example, if we want to consider the range of ages for people that are in high school. And let's say we're not going to include people that repeat or people that skip grades. We're just going to be looking at people who are normal aged, and we'll say those years range 18 is the upper limit, and we'll say 14 is the lower limit. So 14 to 18 years old, we'll do 18 minus 14, that gives us 4 year is the range. So that tells us the range of ages, or the range of a number in that set of values. The next thing we want to look at is the median. The median is simply the middle value. So if we have a bunch of numbers, we'll say 1, 2, 3, 4, 5, 6, 7, right? The median is the value in the center. Okay? And it doesn't matter if the values are skewed, so we have 1, 1, 1, 2, 3, 4, 5. 2 is our center value. Okay. The next one I want you to know is the mean. This does not come up in this problem, but the mean is just the average value. The average value. And the average is determined with the following formula. Average is equal to the sum of values divided by the total number of values. So for example, if we're using this example, we would have a 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. That's going to be what? 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, 5, 15, 6, 21, 7, 28. 28 divided by, there are 7 numbers here. So the 28 is the sum of values, and there are 7 values here. So 28 divided by 7 would give us our average in this case. Okay. Alright, there's a couple of other terms that can be of use. The next one is going to be mode. Mode is the most common value. So in the previous example here, if we look at this one, we can see 1 appears 3 times, so 1 would be our mode here. We also have the min, or minimum. As its name implies, it's simply the smallest value. So again, with this first example here, we have 1, and we also have a maximum. So if in that same example, we have 7. Alright, finally, with some values, we also consider a number called standard deviation. And this is simply a measure of distance from the mean. And we may look at standard deviation in more detail in further problems. Alright, so with all of that background information out of the way, we now have a basic idea of what the median and the range mean. So if we have the simplest possible case where median is our center value and we have a range of numbers, we'll say our starting value and our ending value, where median is in the middle, that's 180 pounds. If we have a range of 30 pounds, that means we're going to have 30 pounds to the left and right, or rather 30 pounds split between the left and right. So if we split this evenly, that's 15 pounds to the right, 15 pounds to the left. 180 plus 15 is 195, and 180 minus 15 is 165. So this is just our simplest example. Now I'll note that the median here, as the center value, if we shift everything here by 10 pounds, so each man gains 10 pounds, we move 165 over to 175. We'll say it right about here. 175. We move 195 over to 205, right about here. And then we move 180 to 190. And we'll see that even though each number has increased by 10, the range here still remains 30. We can also see that the median here has shifted to the right. So if we look at our answer choices, we can see that our median has increased, our range has stayed the same, so that will be answer choice A. Alright, here we have problem number 5 from test 2 of the test prep books, TSI assessment. If we look here, we are given the equation x squared minus 2x minus 2 equal to 0, and we're asked to find one of the roots of this equation. Alright, so previously when we've worked with a quadratic function like this, we could solve it one of two ways. We could factor it, or we could use the quadratic formula. On this particular problem, you can factor it, but you won't be able to use whole numbers, so this will be much more difficult to factor. Instead, what we're going to do is we're going to jump straight into quadratic function. So if you recall, the quadratic function is given as x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that, divided by 2 times a. If we look at our original equation, we can recall that a is the value in front of x squared, b is the value in front of x, and c is the value in the numeral digit. If we plug these values in, we get negative b is negative 2, don't forget the negative sign, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, and c, which is negative 2. All of that divided by 2 times a, which is 1. We start simplifying. Negative times negative is positive, so we get 2 plus or minus the square root of 2, or negative 2 squared, the negatives will cancel, negative 2 times negative 2 is positive 4. And then we have negative 4 times 1 is negative 4, then again times negative 2 is positive 8. The negative signs cancel, so we get positive 8. Okay. All of this divided by 2. Alright. Next step here, we have 2 plus or minus the square root of 12 divided by 2. Now one thing we'll note about 12 is 12 can be broken down into 4 times 3. Now you might be asking, why are we doing that? Well, if we have the square root of 4 times the square root of 3 divided by 2, we know that the square root of 4 is 2. So we're left with 2 plus or minus 2 times the root of 3 divided by 2. If we now carry the 2 through, 2 divided by 2 is 1 plus or minus 2 divided by 2 again is 1. So we'll get rid of the 1 because there's a 1 in front of the 3, which is understood. If we look at our answer choices, we have one of our answer choices is going to match here. And that is going to be answer choice A, which is 1 plus the square root of 3. Alright, so here we have problem 6 from test 2 from the test prep books, TSI assessment. So in this problem, we're asked to find the product of the following sum. So what we have here is we have two polynomials, 4x minus 8 times 5x squared plus x plus 6. You may recall previously when we worked with simpler cases where we had a value times x plus b multiplied by a value times x plus another value, d. Now these are just 4 different values. They can be any values. But for this case, we use something called FOIL. FOIL was a method that allowed us to determine the order in multiplication, or the order of operations for multiplication. So we had first outer, inner, and last. And this helps us to organize our thoughts. So we first multiply the first values in the two parentheses, then the outer values in the two parentheses, then the inner values in the two parentheses, and finally the last values in the two parentheses. And we would then add up each of these values, so we'd have a times c x squared would be our first. Our outer would be a times d times x. And we're adding each of these. Then we have b times c times x. And then finally, we would have b times d. Alright, so this is FOIL. This is a simpler case than what we're dealing with here. But what we're dealing with here, we can follow a similar pattern. In order to prevent ourselves from getting lost or making mistakes, what I'm going to do is I'm going to draw a line for each multiplication. 4x needs to be multiplied by each of these values. So I'm going to draw a line to indicate them. And then I also need to multiply -8 by each of these values. So I'll draw a line for each of those. And then we'll just add up each multiplication. Starting off, we have 4x times 5x squared. That is 4 times 5 is 20. So we have x times x squared is going to be x cubed. Next we have 4x times x. 4 times 1 is 4. And x times x is x squared. Next we have 4 times 6, or 4x times 6. So 4 times 6 is 24. And then we have just x. Next we have -8 times 5x. So -8 times 5 is 40. And we have x squared. -8 times x is up next. So that leaves us with just -8x. And then finally we have -8 times 6, which is -48. Alright. So now, what we want to do is we want to combine like terms. What that simply means is we want to find values that have the same power of x. So here we have x cubed. We'll underline that, and we'll underline every value x cubed. There are no other values of x cubed, however. So now I'm going to draw a caret underneath x squareds. So here's an x squared and here's another one. Now I'll draw a half circle under x's. So here we have an x here and an x here. And then finally I'll draw a squiggly line underneath values with just a numeral. Alright, using these as an indicator just to kind of keep my mind organized, we're going to arrange by order of polynomial. So 20x cubed is out first, then plus 4x squared minus 40x squared plus 24x minus 8x minus 48. Now you'll notice I haven't done any actual math here, I've just rearranged. Now I'm going to combine like terms, which means to find the values that are next to each other and add them together. So 20x cubed is left as is because there are no other x cubed terms. Then we have 4x minus 40x. That gives us -36x squared. Then we have 24x minus 8x. That gives us 16, positive 16x minus 48. And if we look at our answer choices, we can see that this matches with answer choice A. Alright, so here we have problem 7 from test 2 from the test prep books, TSI assessment. Alright, so here I've drawn a rough sketch of the graph shown in the problem. It's not quite exact, but it helps us to understand the problem. So here we can see that we have a graph where the x-axis is time in seconds and the y-axis is position in meters. We are asked to determine how to best interpret the graph on the time from 1 second to 3 seconds. Alright, so to begin with, we can note that the y-axis represents a movement in position. So as we go up in the y-axis, we are moving, though that does not necessarily mean we're moving along a y-axis. It just means we're moving. It doesn't matter where we're moving, but our position is changing as the y-axis increases. So from 1 to 5, 1 to 3, we go from 5 to 15, which means we move 10 feet or 10 meters. Therefore, answer choice A cannot be true. We are moving. The next thing that we look at is the slope. The slope of the line here we can determine. If you recall the slope formula, m is equal to delta y over delta x, or rise over run, as you might be more familiar with. This is simply done by taking the y value of the second point. In this case, we'll use 3. And then for the first value, we'll use 1. So the position at time 3 is going to be 15. The position at time 1 will be 5. The time at time 2 will be 3. And the time at time 1 will be 1. So 15 minus 5 is 10. Divided by 3 minus 1 is 2. 10 divided by 2 simplifies to 5. And this is represented as the top values. These are in meters. And the bottom values are in seconds. So we get 5 meters per second. If we look at our answer choices, we can see this matches with answer choice B. Now you should be careful. One of the answers is 5 miles per hour. You'll note this is meters, not miles. If you're curious what the shortened form of miles is, we typically write MI. Here we have problem number 8 from test 2 from the test prep books, TSI assessment. So here we have a polynomial y is equal to x squared plus 3x minus 4, and we're asked to determine what is the y-intercept of this equation. Alright, so this one is very simple if you know a very basic bit of information. So this bit of information is that the y-intercept occurs when x is equal to 0. Now if we think about a graph, right? We have x and y. The y-intercept, that is the passing of the y-axis, will occur when x is equal to 0. So x being 0 on the y-axis, any point that passes the y-axis is going to have x equal to 0. That being the case, if we plug 0 into our equation, y is equal to 0 squared plus 3 times 0 minus 4, we will find that y is equal to negative 4. So very simply, by plugging in 0, we find that y is equal to negative 4. Alright, so here we have problem number 9 from test 2 of the test prep books, TSI assessment. Alright, so looking at the equation here, we're given 5b minus 4 is equal to 2b plus 17. We simply need to solve for b. So I'm going to begin by subtracting 2b from both sides because the 2b is the smaller b value. We don't want to subtract 5, we want to subtract 2. That leaves us with 3b on the left side and no b on the right side. Before I move on, however, I want to go ahead and in the same step, we want to move 4 to the other side because we've canceled b on the right side, so we want to move 4 to the side without b. And so that gives us 17 plus 4, which is 21. So now we have 3b equal to 21. If we divide both sides by 3, we will find that b is equal to 7, and that is our answer. Alright, so here we have problem number 10 from test 2 from the test prep books TSI assessment. So here we're told that Dwayne has scored a 78, 92, 83, and 97 on his previous exams. We're then asked to determine what score does Dwayne need to get an average of 90 on his exams. Okay. So first off, we'll recall from earlier when I told you about the mean, the average value is simply the sum of values divided by the number of values. Okay? Alright, so if we plug in our known values, we'll find that the average of 90 is equal to the sum. We're going to take our values here, 78 plus 92 plus 883 plus 97. All of these plus our unknown value, and we'll assign the variable x for that, and then divided by the number of tests. So we have the original 4 plus our unknown. That gives us 5. Alright, so now we want to solve this equation for x. We begin by multiplying both sides by 5, so that the 5 on the bottom here will cancel. When we do so, 90 times 5 comes out to 450. Now, the summation of these numbers is a little bit easier than we might expect. 78 plus 92, they've kind of lined them up, so 8 plus 2 and 3 plus 7 will give us values of 10. So 78 plus 92 is going to be 80 plus 90, you can think of it that way, is 170. And then we have 83 plus 97, that's going to be 80 plus 100. So 180 plus 170, you can think of it as 18 plus 17, just to kind of make it a little simpler in your head, is 350 plus x. And if that kind of trick doesn't work for you, you can just add them up in the calculator. But this one's meant to be able to be done in your head. Then if we subtract 350 from both sides, we will find that 100 is our missing value. So Dwayne needs to score a 100 on his next exam to gather an average of an A for his exam grades. Alright, so next up we have problem 11 from test 2 of the test prep books, TSI assessment. Alright, so for this problem I'm just going to show the graph on the screen and then I'm going to talk about it. So here we're given a graph of the top 3 students in each of these teachers' classes, and we're asked to determine which of them has the smallest range. Now the simplest way to do this is just by kind of looking at it by inspection. We can immediately tell that the first graph for Mr. Lennon has the smallest range because it has the smallest difference in the highest and lowest scoring students here. But if we don't want to use inspection, we want to actually kind of calculate the numbers, we can go ahead and develop a very basic table. Alright, so here I've drawn a very basic table where we can see on the left column I have students, student 1, 2, and 3, and then on the top I have the names of each teacher. So as we go across, this will be student 1 and Mr. Lennon, student 1 and Miss Daly, and so on. Student 2 and Lennon, student 2 and Daly, and so on. And then on the bottom here we have a range where we'll calculate the range based on the values for each student. Looking at our graphs, we can roughly estimate that Mr. Lennon's students scored grades of 88, 90, and 92. Now these are rough values, they don't have to be exact, but they kind of give us an idea. Next, looking at Miss Daly's class, we see we have a 92, a 76, and a 90. Again, rough values. Mr. O'Shea, we have 78, 89, 86. And finally for Mr. Taylor, we have 72, 80, and 77. Now if you'll recall previously we discussed that range is the difference between the smallest and largest value. So here we have 92 is the largest, 88 is the smallest, 92 minus 88 is 4. Next we have 92 minus 76. So 92 minus 76 is going to be 16. Next we have 89 minus 78, that will be 11. And then finally we have 80 minus 72, which is 8. We can see then by plugging in numbers that Mr. Lennon has the smallest range, so thus we've proved with numbers that our initial visual inspection was correct. Alright, here we have problem 12 from test 2 of the test prep book's TSI assessment. So on this problem we're asked to determine the probability of rolling a 6 on at least one of 2 rolls of a 6-sided dice. So this requires a lot of background information. The first thing we need to know is that we write the probability of an event, A, in this form, or P of A is simply shorthand for probability of A. The probability of an event, A. Okay. So we can say then that the probability of rolling a 6 on a 6-sided die is going to be 1 out of 6. There are 6 sides and one of them is 6, so we have 1 out of 6. That's very basic. However, we need some additional information because we're asked to determine the chance of getting at least one of 2 rolls. Okay. To help us visualize this problem, we're next going to use something called a Venn diagram. So if I draw a box here, we can say that this box represents the area of all possibilities of outcomes that can happen. Next, I'm going to draw a circle. This circle represents the chance of rolling a 6 on my first die roll. So we'll draw a small circle here. It's maybe not exactly right size, but let's say that represents 1 out of 6 of the area. And then I'm going to draw a second circle here in red that represents the chance of rolling a 1 to 6 on the second die. Now they're a little bit different sizes, but imagine they're the same size. We can say then that there is an overlap between rolling a 1 and 6. So we can get a 6 on our first die, and we can get a 6 on our second die, but it's most likely that we'll only get a 6 on the first die or a 6 on the second die. Alright. So keeping this in mind, this will help us with our next part. When we're determining the possibility or the probability of rolling at least 2 1s, what we want to do is something called find the probability of event A or B happening. So in this case, the probability of A is going to be our first 6. So this is our first 6. And the probability of B is our second 6. Okay. And we can represent this formula, probability of A or B happening, is given as the probability of A plus the probability of B minus the probability of A and B. Alright, well now you might be asking, okay, what's the probability of A and B? Okay, this is easier explained with the Venn diagram. The probability of A or B is simply the total area represented by these 2 circles. The probability of A is the area of the blue circle, probability of B is the area of the red circle, and here we have an overlap that's counted twice, so we subtract that overlap so it's only counted once. We've taken A, which is blue, B, which is red, we've taken out the middle so that we don't count it twice, and that middle value here, the probability of A and B, is calculated simply by multiplying probability of A times probability of B. If we plug this equation into this equation, we will find that the probability of getting at least 1/6 is equal to the probability of A, which is our first 6, plus the probability of B, which is our second 6, minus the probability of A and B, which we know is simply A times B. And if we plug in our known values, where each of these is a probability of 1 over 6, that probability is 1 over 6 plus 1 over 6 minus 1 over 6 times 1 over 6. If we start from the right side, 1 over 6 times 1 over 6 is going to be 1 over 36. So we get negative 1 over 36. Then we have 1 over 6 plus 1 over 6 is 2 over 6. Okay. Next, we need to add these two fractions together. In order to add these two fractions together, I want to rewrite my 2 over 6 as a fraction over 36. In order to do this, we can imagine that we multiply by 6 over 6. 6 over 6 is the same as 1. So we've not changed anything. We don't need to multiply anything on the other side. Since we're just multiplying by 1, nothing's changed. We just have 6 times 2, which is 12, divided by 6 times 6, which is 36. So we have 12 over 36 minus 1 over 36, which will give us 11 over 36. And that is our answer. Alright, here we have problem 13 from test 2 from the test prep books, TSI assessment. So here we're given an ordered pair, -3, -4, and we're asked to determine what happens to this point when it's reflected over the x-axis. This can help if we draw a graph, just to kind of visualize it. We have x and y here. We have point -3, -4. If we go over 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. This is our point here. This is our starting point. We're asked to reflect it over the x-axis, which is this one here. So if we reflect it over the x-axis, we're just going to draw a line over here, and we're going to go up 1, 2, 3, 4, and this will be our point right here. And this point, it has the coordinates -3, +4. Very easy problem if you use the graph. If you don't use the graph, you might trick yourself because you think it's over the x-axis, so you might think to flip the x value. It's actually the opposite. When we reflect over the x-axis, the y value, the sign flips. If you reflect over the y-axis, the x value's sign flips. Alright, so here we have problem 14 from test 2 from the test prep books, TSI assessment. This problem is relatively straightforward. We're just simply asked to find x in the following inequality. We'll begin by simplifying the left side of the equation. -3 times x is -3x. -3 times 4 is -12. Next, we want to subtract x from the right side so that we have all of our x's together on the left side. And we want to add 12 to both sides to get rid of the 12 on the left side. So we have x by itself as -4x. So we have -4x greater than or equal to 8 plus 12 is 20. Now we want to get x by itself again by dividing by -4. So we divide both sides by -4. We get x on the left side, and on the right side we get 20. Divided by 4 is 5, and there's a negative sign, so -5. Now it's important to note when we divide or multiply an inequality, whether that be greater than, equal to, less than, equal to, greater than, or less than, any of these inequalities, when we divide or multiply by a negative number, the sign will flip. So we get x less than, equal to, -5. That is our answer. Alright, next we have problem 15 from test 2 from the test prep books, TSI assessment. Alright, so looking at this, we're given a table and we're asked to determine an equation that matches with this table. Alright, so to begin with, when we have a table and we're told that this is a linear equation, we can determine the slope by simply using two of these points to determine our slope. We recall that slope is given as rise over run, or change in y over change in x, where y is our dependent variable or our output, and x is our independent variable or input. That being the case, our input is going to be sales, that's the number of things she sold, and her output is going to be how much she makes as a result. So we need to look at the change in pay over the change in sales. If we use any two values here, it doesn't really matter which ones we use. We want to use the smallest ones because they're going to be the easiest numbers to work with. So we'll choose 2 with 380 and 4 with 460. Plugging those in, starting with pay, we start with the larger value, 460, minus the smaller value, 380, divided by the larger value, 4, minus the smaller value, 2. And we get 460 minus 380 is going to be simply 80. And then 4 minus 2 is 2. 80 divided by 2, that's going to give us $40 per sale. This is our slope of our line. So now, if we're looking at slope-intercept format, we're looking at something like this, where B is our unknown value. In order to find our B or our y-intercept, we simply need to plug in any one of these points. And again, we'll use the simplest point, so we'll use value 2 with 380. So we plug in 380 on our y value, this is our output, with 40 as our slope, times 2 as our input. We can then solve for B. So 40 times 2 is 80. So we get 380 equal to 80 plus B. Subtract 80 from both sides, and we get that B is equal to 300. I'm just rearranging it, flipping. So we have B equal to 300. And if we plug this into our equation, we get Y is equal to 40x plus 300. And that is our answer. Alright, here we have problem number 6 from test 2 from the test prep books, TSI assessment. We're given this system of inequalities and asked to determine which of the following coordinates is a solution to the set of inequalities. There are two different ways that we can solve this problem. The first way that we're going to look at is to use something called a test point. So a test point is when you plug a value into an equation to see if it's true. So we do this with inequalities to figure out whether these values match with the inequalities. We're going to start with Roman numeral, we're going to start with answer choice A and work our way down to answer choice D. So if we plug in 4 comma 5, where 5 is our y value, 4 is our x value, into our first equation, we have 5 and then 2 times 4 minus 3. And now we don't know that it's going to be greater than. So what we're going to do instead is we're going to write a question mark. We want to know how is this relation. So if we simplify, we have 5 on the left side, and then we have 2 times 4, which is 8. And then we have 8 minus 3, so 5, 5, and we find that 5 is equal to 5. Here we have less than. It's not less than equal to, it's just less than. So this one cannot be true, and we don't need to continue to the second equation. Alright, now let's test the second coordinate with our first equation again. Plug in -2 for the left side, and then we don't know if it's equal to, and then we have 2 times our -3 here, minus 3. Simplifying, we have -2, and then we have 2 times -3 is -6 minus 3, and we have -2 again, and then on the left side, or on the right side, we have -6 minus 3, the -9. We can say that -2 is greater than -9. Now this might be confusing. You say 9 is bigger than 2, but it's a negative number, so -2 is more positive than -9. So this one holds up. Now we need to check it against the second equation. If we plug in, again, our negative 2 on the left side, and we don't know how it's going to be equal to or less than, greater than, so we'll use a question mark, and then negative 4 times negative 3 plus 8. So negative 2 somehow related to negative 4 times negative 3 is positive 12 plus 8, and that gives us negative 2 is less than 20. And we can see that this matches with our sign, so we can then say, since it matches both, since it meets both criteria, that our answer choice is going to be answer choice B. But let's go ahead and go through each of the other ones just for extra practice. Alright, so I'm going to move down here, and for answer choice C, we plug into our first equation, negative 1, 2 times 3, minus 3, negative 1, somehow related to 2 times 3, which is 6, minus 3, and then we get 6 minus 3 is 3, and we find once more that negative 1 is less than 3, which does not match the sign direction, so this cannot be our answer. Moving on to the next one, we have 2 on the right side, on the left side, somehow related to 2 times 5 minus 3, 2 somehow related to 2 times 5 is 10 minus 3, and we have 10 minus 3 is 7, 7 is greater than 2, which once again is not the correct direction for our sign. So through a process of elimination, we can determine that our answer is answer choice B. Alright, so I mentioned at the beginning of the problem there were 2 ways we can solve this problem. The other way is using a graph. So if we start off, what we want to do is we want to graph each of our equations. Now these are inequalities, so they're not graphed quite the same way, but the basic idea is similar. Starting with y greater than 2x minus 3, we'll graph just like normal. We'll go in and find our y-intercept, which is at minus 3 here. And then we have a slope of 2x, so we want to go up 2 over 1. And we're going to keep repeating this just to kind of fill out our graph a little bit. And again, just remember this is a rough sketch. It's not going to be exact. And if I then draw a line, now here's where it differs with a inequality. Since this is not greater than equal to, it's just greater than, I draw a dotted line because we don't actually have values that are equal to this graph. Okay. Next, we want to look at our second equation. Y is equal to, or y is rather less than negative 4x plus 8. So we go up here to 8. And we need to go down 4 over 1. So down 1, 2, 3, 4 over 1. Down 4 over 1. Down 4 over 1. And again, this is just a rough sketch, so it's not going to be necessarily exactly right. And again, since this is a inequality, this is a dotted line. So I'm just going to mark out there so you can see it's dotted line. Alright, now we need to determine which way it opens up. In order to do this, again, we're going to use a test point, but this time we're going to use the origin here, 0, 0 as our test point, because it's very easy to plug in. So if we look at our first equation, if we plug in 0, we have 0 greater than 2 times 0 minus 3. So what we're looking at is 0 on the left side, negative 3 on the right side, and we can agree with ourselves that 0 is greater than negative 3. So our first equation here is going to open up this direction. and just kind of shaded in a little bit there. Alright, then our second equation, if we plug in zeros, we have 0 on the left side, negative 4 times 0 is 0, and we have 8 on the right side. We can agree that 8 is greater than 0, so this equation also opens on the left side. Okay. So looking at these two equations, we can tell that the overlap, which is this area here, so from here and here, this is our area. This is the part we care about, is this left side here. Alright, now if we plug in each of our points, we go to 4 and then up 5, we can see we have 4, 5 here is on this line. It's not in that area that we're interested in. Then we have negative 3, negative 2. So we go over 3, down 2. We can see this point. Again, we've already proved that this one matches, but we can see this point is inside of our area that we're interested in. Then we have over 3 minus 1. That's down here and it's outside of both areas. Then we have finally over 5 up 2. So over 5 up 2. Once again, these 2 points are completely outside of the area. This point is on the line, so also completely outside of the area. And this one is inside both areas that we care about. Alright, so here we have problem 19 from test 2 from the TSI assessment from test prep books. Alright, so here we're asked to find which of the following equations has an x-intercept of x equal to negative 2. Alright, so similar to when we previously looked at finding the y-intercept of a more complicated equation, we can note that the x-intercept is simply found when y is equal to 0. So when y is equal to 0, this gives us our x-intercept. So if we start from our first equation, y is equal to 2x minus 3. If we plug in our values, 0 for y, we get 2x minus 3, add 3 to both sides, and we get 3 equal to 2x, divide both sides by 2, and we find x is equal to 3 over 2, and this is not the value we were looking for. Looking at answer choice B, we have a y equal to 4x plus 2. Here, if we plug in 0 for y, and then we subtract 2 from both sides, we find that negative 2 is equal to 4x. Divide both sides by 4, and we get x is equal to negative 2 divided by 4, can be simplified down to negative 1/2. Next, we have y is equal to x squared plus 5x plus 6. If we plug in 0 for y, we get 0 is equal to x squared plus 5x plus 6. Alright, so now we have a polynomial that we need to factor out or use quadratic equation. I'm going to do a factorization. So again, for factorization, we want to get a form that looks like this, where we have x plus a times x plus b, where a and b are unknown. The next step is we look at 6, and we want to form a factorization tree. So 1 and 6, and 2 and 3. These are our two sets of possibilities, so it's either 1 and 6 or 2 and 3. And we need to get, if we were to FOIL this working backwards, we need to get ax plus bx equal to 5x, which is our middle term, and we can use only these values here. We can see that 2 plus 3 is 5, so a is equal to 2, b is equal to 5. We get x plus 2 times x plus 3 equal to 0. If we divide by either one of these, we will find the opposite equation. So what we get is x plus 2 equal to 0, and x plus 3 equal to 0. If we solve both of these, subtract 2 from both sides, we get x is equal to negative 2, which is what we're looking for. But just for the sake of completion, we'll go ahead and subtract 3 from both sides on this one. We get x is equal to -3. Alright, also, for the sake of completion, we'll go ahead and complete the last answer choice as well. But this one is going to require a little bit of advanced math. Alright, so finally, plugging in 0 for y, we get 0 is equal to -1/2. And here the x indicates, or the x in the middle is actually multiplication. So -1/2 times 2 to the x power. If we divide both sides by -1/2, or multiply by -2, whichever you prefer, we will get 0 is equal to 2 to the x. Okay. We need to cancel the 2 so that we're left with x, and in order to do so, we use something called a logarithm. A logarithm is simply a form of a logarithm is a tool kind of like multiplication, subtraction, division, addition that allows us to cancel an exponent or cancel the base of an exponent. So if I take the logarithm with a base of 2 of 0 and I take a logarithm of a base of 2 on both sides of 2 to the x, what this means is I'm canceling out 2 with the log base 2, and the logarithm is going to leave me with just what's in the power. So logarithm of 0, we'll get to that in just a second, but the logarithm base 2 of 2 to the x gives us on the right side just x, the 2 is canceled. Logarithm of any base of 0, however, is going to be undefined. And if we were to graph this, what that means is it goes towards infinity. So you might have a graph that, let's see, logarithm is going to be, so it'll look like this. Here if we have an x and y at infinity, it goes to negative infinity from this direction and goes like this. And so we can tell then that this one, again, is more of a complicated answer, it goes to infinity, but we can tell that this does not have an x-intercept of -2. Alright, so here we have problem 17 from test 2 from the test prep book's TSI assessment. In this problem, we're told that we have a rectangle with an area of 24 centimeters squared, and we're asked to find out what happens if the side lengths are multiplied by 3. So, to begin with, we know that the area of a rectangle is given as length times width. If we write the equation for our first rectangle as area 1, then we can say that the area is made up of length 1 and width 1. If we then say that our second rectangle, our new rectangle, is going to be given as area 2, we can say that it's made up of length 2, width 2. And we know from our equation that we're multiplying length 1 and width 1 by 3 to find our new length and width. So we have length 2 is equal to 3 times length 1, and width 2 is equal to 3 times width 1. If we plug these two equations in for area 2, we get 3 times length 1 times 3 times width 1, which is, if we multiply through, we get 9 length 1, width 1. And length 1, width 1 is the same as area 1, so we have 9 times area 1, and we know we're given that area 1 is 24. If we multiply 9 times 24, we get 216 centimeters squared, which is answer choice C. Here we have problem 18 from test 2 from the test prep book's TSI assessment. Alright, so in this problem we are given the following figure and we're told to find the perimeter of the outer edge of this shape. Here we have sort of a square with a semicircle attached to the side. Now, the perimeter of a square is simply the sum of each of its side lengths. So this would be side length 1 plus side length 2 plus side length 3 plus side length 4, whereas this would be 1, 2, 3, and 4. However, we've cut off one of the side lengths, so we're only dealing with 3 side lengths. And the perimeter of a circle has a special name called a circumference, given by the letter C. So this is circumference. And the equation for circumference is 2 times pi times r, where r is the radius, the distance from the center of the circle to the edge, which we're given here is 4 inches. And pi is a constant, which is approximately equal to 3.14. Alright, so using all of this information, we can determine that the perimeter of this object is 3 times the side length, because we're leaving off one of these edges, plus pi times r, or rather 1/2, okay. Alright, so our circumference here, 2 pi r, gives us the perimeter of the entire circle, but we're only dealing with half of the circle, because half of it's inside. So what we're looking at here is the perimeter of the whole shape is given as 3 times s, because we've left off the one side, plus pi times r, because we've only taken half the circumference. If we plug in our values, we have 3 times s, which is 8, is our side length, plus pi, which is 3.14, times r, which is 4. 3 times 8 is 24, and if we multiply out on the side here, or you use a calculator, we can find 3.14 times 4. 4 times 4 is 16, carry up the 1, 4 times 1 is 4, plus the 1 is 5, 4 times 3 is 12, so we get 24 plus 12.56, add the two together, and we get 36.56, and this is just an approximation, but you can see that one of our answer choices is 36.565, and that is our answer. Alright, so here we have problem 20 from test 2 from the test prep books TSI assessment. So here we are told that a couple pieces of information. First, there are 3 girls for every 2 boys in Jim's school. Second, there are 650 students. We are asked to determine how many girls there are. For this problem, we can use a simple ratio. Now, there is one small trick though. We want to do a ratio of the number of girls to the number of students. If there are 3 girls and 2 boys, or 3 girls for every 2 boys, that means that there are 3 girls for every 5 students. Where students is the addition of the 3 girls and the 2 boys. So we have 3 girls for every 5 students, and that's going to be equal to the number of girls total out of the 650 students. If we then take this ratio, 3 over 5 is equal to x over 650, and we multiply both sides by 650, we get that x is equal to 650 times 3 divided by 5, okay? So this will be easier if we first look at 650 divided by 5. 650 divided by 5, we get 1 minus 5, 1, bring down 5, 5, 3, and then bring down 0. We get 0. So 650 divided by 5 is 130. 130 then multiplied by 3 is simply 390. So x is going to be equal to 390. This is the number of girls in the school.